All right, on tonight's episode of Python Papi, we're back inside our artificial intelligence course, and we're still doing our neural networks module. Let's have a look at what we went over tonight. Now, last night, if you recall, the last thing we went over was the stochastic gradient descent, and tonight we're going to pick up where we left off. So, with the stochastic, we start with a random choice of weights, and we repeat this process of calculating the gradient based on one data point, direction that will lead to decreasing loss. We update the weights according to the gradient. So the idea here is that we have some setting of the weights. We pick a data point, and based on that one data point, we figure out in which direction should we move all of the weights and move the weights in that small direction. And then take another data point and do that again. And repeat this process again and again. Maybe looking at each of the data points multiple times, but each time only using one data point to calculate the gradient. Calculate which direction we should move in. Now, just using one data point instead of all the data points probably gives us a less of an accurate estimate of what the gradient actually is, but on the plus side, it's going to be much faster to be able to calculate. We can much more quickly calculate what the gradient is based on one data point instead of calculating based on all of the data points and having to do all of that computational work again and again. So there are trade-offs between looking at all the data points and just looking at one data point. And it turns out that a middle ground that is also quite popular is a technique called the mini batch gradient descent. Now, this is the mini batch gradient descent here. And basically, it's just the same as the other two, the regular gradient descent and the stochastic gradient descent. But with the mini batch gradient descent, we're going to start the same process of starting with a random choice of weights. And we're going to repeat this process of calculating the gradient based on a small batch, a direction that will lead to decreasing loss. We update the weights according to the gradient. So where the idea here is instead of looking at all the data versus just a single point like the other two, we instead divide our data set up into small batches. So with the gradient descent, we look at all of the data points. With the stochastic, we look at one particular data point at a time. And with the mini batch, it's kind of like a hybrid where we look at a batch version of our data sets. Groups of data points where we can decide how big a particular batch is. But in short, we're just going to look at a small number of points at any given time, hopefully getting a more accurate estimate of the gradient, but also not requiring all of the computation and effort needed. Wait, I lost my, sorry. To look at every single one of the data points. So the gradient descent then is the technique that we can use in order to train these neural networks in order to figure out what the setting of all these weights should be. We want some way to try and get an accurate notion of how it is that this function should work. Some way modeling how to transform the inputs into particular outputs. Now, so far, the networks that we've taken a look at have all been structured similar to this. You see here we have three inputs all leading to one output. We have some number of inputs, maybe two or three or five or more, and then we have one output that is just predicting like rain or no rain, or just predicting one particular value. But often in machine learning problems, we don't just care about one. But often in machine learning problems, we don't just care about one output. We might care about an output that has multiple different values associated with it. So in the same way that we can take a neural network and add units to the layer or add units to the input layer, we can likewise add outputs to the output layer as well. Instead of just one output, we can imagine we have two outputs or maybe even four outputs, for example. Where each case, as we add more inputs or more outputs, if we want to keep the network fully connected between the two layers, we just need to add more weights. Now I'm going to stop it there for the night, but that's the gist of what we went over. We did take a lot more notes, but I'm not going to dive into everything right now. You pretty much got the gist of all the different gradients that we went over, the three different gradients we went over so far, the gradient descent, the stochastic gradient descent, and the mini batch gradient descent. So yeah, we will pick it up tomorrow, and of course, I will keep you guys